WheresWaldo AI group, and our group consisted of Joseph Nguyen, Justin Kelly, and Sam Gibson.
The Where's Waldo puzzle books were first created in 1987 by Martin Hanford. The concept of the puzzle is simple. Find the character Waldo within the pages. However, it's much easier said than done. The number of characters on the pages can range anywhere from 200 to 500 characters. The scenes in these pages are obviously extremely complicated, and it is easy to lose track of where Waldo is. Our goal with this project was to create an AI that could quickly locate whether or not Waldo appeared in the image with a high confidence rating. This project is a great example of the capabilities of even a simple neural network.
And the dataset we used was found on Kaggle, and the dataset only contained 19 full-size images of the Where's Waldo pages, and the rest of the dataset was cutouts with various pixel ranges, like 64 by 64, 128 by 128, and 256 by 256.
One problem we quickly realized at the beginning of this project creation was that the number of images that did contain Waldo were vastly outnumbered by the number of images that didn't contain Waldo. So one way we solved this problem was to artificially create more images by augmenting the images that did contain Waldo, as you can see below, by distorting and rotating the images that did contain Waldo.
And for training, we trained our model based on colored images of 64 by 64 pixels. And at first, we used various numbers of epochs and batch sizes to determine which would give us the best accuracy. But at the end, we found that with 100 epochs and a batch size of 64, we were able to get consistent accuracy. And our data set was split into two different sets, 81% of the images being training and 19% of the images being validation.
Throughout the lifetime of our project, we tested out a couple different variations of our neural network, and we decided on two final ones. The first one had 256 neurons and was 18 layers deep, while our second model had 161 neurons and was 12 layers deep. Eventually, after some testing, we found that our first model was the most effective. It was able to reach a 93 to 96% accuracy rating and a 14 to 19% loss on our training set data.
And how this model works. So we tried various network architectures and found the most optimal and saved that model for actually testing to find Where's Waldo. So to run our project, we load the model, and so we don't have to run the epochs and batches again. And when the user passes in the image as an argument, the model will determine Where's Waldo, and we'll also give a cutout that draws a box around Waldo.
Running our project is pretty straightforward. You would just run the Python 3 command on the actual application, which is main.py in this case, and then you would pass in an image such as contains Waldo, or the image in the bottom right-hand corner. And our project would do some calculations and split up the image into segments, and then would find the segment that it felt had the highest confidence rating of containing Waldo, and would draw the green box as mentioned before and as pictured in the image in the bottom right-hand corner.
And in conclusion, our group set out to create an AI agent that could be passed a random picture and determine whether or not Waldo was present in the picture. And we are confident in the structure of the neural network that we created. And during training, we found that it was important to focus on Waldo's characteristics, like his look and outfit. And if Waldo was present in the picture, our AI was able to accurately detect him with, on average, of 80% confidence score.